సార్ వాయిస్ రావట్లేదు సార్ మీరు. సార్ వాయిస్ రావట్లేదు సార్. సార్ మీ వాయిస్ రావట్లేదు సార్.
పాజిటివ్ అంటే శాంతి మేడం
సార్ మీ వాయిస్ రావట్లేదు సార్.
ఫోన్ చేస్తుంది.
Sorry. Good morning.
గుడ్ మార్నింగ్ సార్.
Previous explained the characteristics of DC motors and the problems related to that one. Now, I will go for speed control of DC motors. Speed control of DC motors means we know that the previous is N is directly proportional to EB by 5, and next one is this EB is replaced as V minus IARA by 5, and I have to assume that proportionality means any constant K, then this is equal to V minus IARA by 5. So this is considered as either equation number 1, both are considered as equation number 1. Now, if you want to control the speed of any motor, what are the parameters is there? This one, K is constant. Now we will go for V. V is one parameter, and another one is IA is another parameter, and RA is another parameter, and phi is another parameter. So here there are the 4 variables, but here you will observe this is either we have to change RA and we have to change IA. Okay, so by how to control the speed? By changing the supply voltage, by changing the flux value, or by changing these two. So I have to assume that once we have to design any motor, armature resistance is fixed. So armature resistance is fixed means we have to control by using I. So what are the variables? What are the parameters we have to control the speed? First one is the V. Second one is we have to design armature, that is motor, armature resistance is fixed. So V, IA and phi. So this is fixed. So the control variables are V, IA and phi. Now go for here. If you want to control the speed of any motor, we are using either first one, armature control method or flux control method. So I have to divide this speed control is divided into speed control of DC motor depends on first one, flux control method. That means the speed of DC motor is varied by using flux. So flux means this one. So it is called flux control method. Flux control. We know that flux is produced due to the field current, due to the field. So it is also called field control method. Flux control method, field control method. Generally, we have to represent as flux. So I have to omit this one because of we get some confusion for this field. So flux control method. Next one, second one. Second one here, armature control method. So armature current control method. Armature current control method or armature control method. Okay, armature current control method. In some cases, this is considered as bracket armature current control method. So I have to represent directly armature current control method or current control method. Third one. Here, voltage control method. Voltage control. So these are the three parameters which are used to control the speed of any motor. Okay. So first, next snapshot for this one. Then I will go for the remaining. So here is RE is constant. So RE is constant. And K is constant. So remaining are variables. Okay. Take the snapshot. Then I will go for one by one. So if you want to go for speed control method, this is already I have explained previous equations. Just we have to write down the previous equation, then I have to explain. Okay. How many minutes? Okay. Now we'll go for one by one. Okay. I'll take the snapshot, then I will go for one by one. Okay. Okay. Speed control of DC shunt motor. Speed control of either shunt motors, whatever it may be. Speed control of DC shunt motor. Okay, so first one, A is what? So if you want to find out or if you want to write down the characteristics of DC shunt motor or DC series motor or compound motor, whatever it may be, first write down the equations previously I have mentioned. Then write down speed control method is flux control, voltage control and current control. Then you will go for speed control of shunt motor. So first one is flux control method. Flux control. So what is meant by flux control method? We know that shunt motor is what? we know that this is the general case of shunt motor. Okay, because the field winding is connected in parallel with motor. But here, flux control method. Flux control method means flux is directly proportional to current passing through the field winding. So the IF is directly proportional to phi. So the current passing the field winding, it changes in regular manner. Then only we have to control the speed of DC motor. We'll observe here. Here once you design like this one, the current passing to the field winding is constant because of we know that previous R this is ISH. ISH is equal to what? V by RSH. Previously I have explained the equations that one. So here V is fixed, RSH is fixed. So the current passing the field winding is fixed. So, but here we have to vary the current. Then only flux is variable. So we'll observe here. We have to give one variable resistor, and that is also called rheostat, which is connected in series with the field winding. So this is called RSH or FF, and here it is called a rheostat. Okay, then the current passing to the field winding is variable by changing a rheostat position. We are well known about machines lab or it may be PDC lab. By changing the rheostat position, suppose at the time of constant, suppose I will consider this is R. So if R is 0, so R is 0 means what? The current passing through this one is maximum. If R is increasing if these two are in series, then current passing through this one is decreases. So by changing the position of rheostat, we have to control the current passing through the field winding. So when current passing the field winding it changes means automatically the flux is also changes. So we know that the previous equation, previous is what? N is directly proportional to or inversely proportional to 1 by 5. Because of what is the equation? V minus IARA by 5. So I have to assume that the supply voltage is constant. The current passing through the armature is constant. And RA is fixed. And only flux is variable. So if you want to use flux control method means remaining two are fixed. So N is directly proportional to or inversely proportional to 1 by 5. So whenever current passing through this one is changes, then automatically N is directly proportional to or inversely proportional to 1 by SH. So the current is passing through this one is minimum or maximum. So speed is inversely proportional to this one. So by changing the flux, we have to control the speed of DC shunt motor or any DC motor. And one more thing is here, suppose if you are consider this ISH is low value, because we know that previous case is what previous problems we have to identify. ISH is equal to either 250 by 100, that is equal to 2.5 amperes like that. If you are connecting a resistance in series with a rheostat in series with the field winding, the current passing the field winding is decreases. Decreases means either 2 amperes or 1 amperes, depends upon we have to connect the rheostat. If field current is less, what about the speed? Inversely proportional. So IF is decreases or ISH is decreases. What is the value of speed? Speed is increases. So this type of speed control method is most probably used in above rated speed applications. Above rated speed applications. Above rated speed applications or above base speed applications. Okay, so this is very important bits. So speed control method is more suitable for above rated speed. Then what is base speed and what is above? Base speed means what? We know that previous is equal to n have one equation is there, EB is equal to 5Zn by 60 into P by A. By using this equation, we have to identify the speed. In general, number of poles is equal to 4. So in normal cases, speed is approximately equal to 1500 RPM. Okay, 1500 RPM. By considering all these things, we have to assume that in general cases, the speed of any motor, a shunt motor or DC series motor, it is called a rated speed or base speed. Then this speed is more suitable for above rated speed. That means speed is controlled in between 2000 to 1500 RPM, in between 1800 to 1500 RPM. So this is called a flux control method. Okay, flux control method, and generally N is equal to 1500 RPM is considered as a base speed. Okay. Okay. Now we'll go for the diagram. What is the diagram is there? Okay. What is the diagram is? Previous I have explained the diagram related to the what is the relation between previous is I have to explain. This is IA and this is speed. We know that this is a constant speed applications. If n is constant and if n is variable, current passing the field winding armature resistance is variable, slightly like this one. This is called the drop, and this is. So previous case will go for shunt motor characteristics, the speed versus armature current. This is the actual current. This is called without rheostat. This is with rheostat. So that means what? Previous cases will get control up to this one. Now we have to control up to this point. So it is called the drop of IRA, and this is called the drop of this one also. So this is the speed control method of, flux control method of DC shunt motor. And take one snapshot, then I will go for the remaining. Are you visible? All of you are visible this one?
Yes, sir.
Okay. Okay, then I will go for next case. This is flux control method. So this is important bit. Above rated speed. Which flux control, which method is more suitable for DC motors? Is a series motor or shunt motor or compound motor? Anything, flux control method. And what is the advantage of this one? What is the advantage means the current passing through the field winding is very less value. That is 2.5 amperes. So if you are connecting the rheostat here, the losses is also very less. So this is very convenient method to control speed of DC shunt motor as well as series motor. Okay, now we'll go for another one. Next one. Armature control method In some cases, they have to write down like this one. Armature current control method. Okay, armature current control method. Sorry, armature control method or armature current control method. Then what is? So this is shunt motor. So field winding is connected. Armature current or control means the current passing through the armature is controlled by connecting a rheostat. That's it. So here this is the back EMF and this is shunt field winding and this is called a rheostat. Okay. Then we'll consider this one is plus and minus. Okay. Now armature control method means what? N is equal to or N is proportional to V minus IARA by 5. So I have to assume that flux is constant and voltage is constant. That means if you want to use any method, remaining 2 is considered as the constant. So it is minus IARA. Here RA is fixed. So only by changing the value of IA, we have to control the speed of DC motor. So this is called by current control method. So we know that N is remaining is considered as constant V minus IARA by 5. Remaining is considered constant. So N is proportional to minus IA. RA is also fixed. So minus means what? Indirectly, sorry. Okay. Here we have to assume that this current voltage is fixed. This current is very negligible value. Negligible value. So N is directly proportional to armature current. N is directly proportional to armature current. Now, by changing the value of this one, by changing the value of IA, the current passing overall drop should be changes or not? V minus IA or a change. Then automatically the drop is changes means we should remember justly EB for convenience. So EB means V minus IA or a drop that is equal to is proportional to EB by pi or EB. Okay, so if IA is increases, the drop is increases. If IA is decreases, the drop is decreases. So the drop is also called armature drop. Armature drop is also represented as overall drop across this one. That is called EB and drop this one. So N is directly proportional to EB. It is also called armature current control method, armature control method. Because why you are called armature control method means this is directly depends upon armature. So we will observe here the speed is directly proportional to EB. EB means if you are increasing the IA value, speed is also increasing. If you are decreasing the speed value, okay. So this is direct relation. So it is called rheostatic control method. Rheostatic. Sorry. This is 1 minute. A previous diagram. Shunt motor. What is the shunt motor? 1 minute. 1 minute. Previous I have explained speed and current. Okay. Now this is IA. 1 minute. Previous graph is related to this one because of IF. Previous I have not explained IF relation. Sir, no. So if you are increasing the IA value at the time of starting, this is the fixed value and IA and IS. So we are observing this one. This is the constant and this is called IARA drop, and this is called, if you are connecting, this is either resistance R, that is called IAR drop. So if you are increasing the value of IA, speed is decreases. What is the reason is N is directly proportional to minus IA. Minus means it is nothing but inversely proportional. That is called inversely proportional. So, but here armature current is always maximum value. Always armature current is always in maximum value. So, if IA is maximum, speed is very less. IA is, so should verify one modifications. Previous I explained this diagram. This is for only this one. Previous there is one. Okay. So N is proportional to minus IA, that is proportional to 1 by IA. So here N is inversely proportional to 1 by IA. Previous is also same. N is inversely proportional to 1 by IF. So, but previous IF value is very less because of 2 amperes or below 2 amperes like that. So speed is controlled in above rated speed. But you will observe in IA. Previous you will consider IA value is 100 amperes, IA value is 1 or 2 amperes like that. So IA is maximum, speed is very less. So in speed control method, flux control method, this one is the rule. And this one, in case of here, IA is maximum means speed is very less. So this method is more suitable for below rated speed. Below rated speed. Why? Because the relation is same. The only difference is current value. IF is very less, so it is used in above rated speed. IA is very high value in normal case, so it is suitable for below rated speed. Okay. So this is in speed control of DC shunt motor. Either armature current control method or armature current control method, or it is also called, because we are connecting here rheostat. Okay, so rheostatic control method. Armature rheostatic control method or armature control method. These are the 3 names for this one. Okay, take the snapshot and I will go for the next topic. And you observe here the current passing through the armature is approximately 100 amperes something. We are connecting a rheostat here. Rheostat either a 10 ohms or 15 ohms or 100 ohms like that. So suppose R value is 50 ohms. What is the I square value? I square R value is what? 100,000 into 50. 5,000. Suppose this is either 5 ohms. What is the value? IA square into RE. IA square is 1000 into 5. Sorry, 100. 100 square means what? 10,000 into 5. 50,000. 50,000 is the power loss watt. So this method is, if it is compulsory, then only we are using. Otherwise, it is not using this method. But nowadays, we have to use, in place of this rheostat, In place of this rheostat, we are connecting one regulator. We know that the speed of fan is controlled by using a regulator. We have to use a regulator like a power electronic devices. We have to connect in series. Then by changing the position, we have to control the speed of DC motors. Why? Because the losses in this case is very less. Okay, that is the main reason. We are well known about EDC subject. EDC is switches is act as a regulators, but we are studying the same subject as power electronics, some modifications. Okay, first go through this, write up, make some snapshot, then I will go for the next one. Go over. Now, C is applied voltage control method. Applied voltage control method. What is meant by applied voltage control method? Applied voltage control method means what? Previous we know that N is proportional to IA RA by pi. Here pi is constant, second term is constant, so N is directly proportional to V. So by changing the value of supply voltage, we should change the speed of DC shunt motor. It is possible to change the supply voltage in normal case. Is not possible. So, in order to overcome this drawback, we have to connect a special arrangement for this one. There are different methods is there. We are not using this one in practical cases. Why? Because it is losses is very high value. But even though we are going to explain applied voltage control method, okay. So this is in general manner. I have to explain how to control the speed by using applied voltage. Okay. Now, suppose I have to assume that the supply is Okay. This one is applied voltage control method. Here, this is also called, this is one method. This is called multiple voltage control method. This is called, so generally in examination point of view, write down applied voltage control method or explain voltage control method or speed control of voltage. We have to use any one method. Don't go for remaining. Here we have to use 3 or 4 one. Applied voltage control method like that. So I have to explain one, and remaining is also a small modification. So it is also called multiple voltage control method. Okay, multiple voltage control method. That one. Here, we'll observe this is the field winding. Field winding is connected across parallel with the motor. We'll observe here this case. In this case, this supply is connected to, suppose this switches is connected to here. Supply 220 volts and 0 volts is connected across armature of the motor. And similarly, 220 volts and 0 volts is connected across field winding. So shunt field winding. So that means field winding is connected across motor. So it is called a shunt motor. Now we have to control the speed of motor by using voltage. So here we'll observe, suppose we are connecting a motor to this one. This one means what? This is 230 volts. 230 volts. So 230 volts means by changing the supply voltage, automatically speed is also changes. Okay. Then suppose if you are connecting the switch is like this one. We are well known about in machines lab. One type, another type. So if we are closing this one, the voltage is phase is connected here and another terminal is connected here. So the difference between these two is approximately what? 440 volts. So here is 440 volts. So one is 430, sorry, this is 220, that is 440. So if you are connecting the motor to this terminal, the voltage is 220 volts. Depends upon the voltage, the speed is variable. Suppose if you are connecting the switches like this one, the voltage is 440. The motor should be very depends upon the supply voltage in direct manner. Suppose if you are increasing the voltage, speed is also increases. If you are decreasing the voltage, speed is also decreases. Then what is the disadvantage here? What is the disadvantages means? Suppose you will observe here, if you are connecting this motor, previous case is approximately 220 volts or 230 volts. So the motor is designed approximately suitable for single phase. Suppose if your motor is connected to this side, the voltage is 440 volts. 440 volts means it is suitable for 3-phase supply. That means the rating should be high value, means automatically the design should be changes. So first one, the cost of this one is more than compared to the remaining one. So cost means the designing of motor, it is suitable for both 220 volts as well as 440 volts. So it is most costly. So normal case, we are not using this type of arrangements. But if you are going for a high power voltages, suppose if you are going for any generating stations, we have to use any power electronic devices or controlling of voltages. That is called AC voltage regulators. Sorry. AC voltage converters. Because of it is AC supply, we have to convert AC to DC. AC voltage converters are rectifiers. We are alone about rectifiers in EDC. Same as here, but only the rating is different. So if you want to control the voltage, this is in previous older version. Now we have to control the voltage. We are using rectifiers, even though it is a costly one. This is one method. This method is called multiple voltage control method. Now another method is also there, that is called B. Ward-Leonard armature control method. Ward-Leonard control method. So I will explain what is the difference between these two. Ward-Leonard control method. Here if you want to control, here only one motor is there and one field winding is there. In Ward-Leonard control method, we have to use one motor, second motor, and generator. So same as this one, but only thing is, if we want to control the motor speed, we are connecting one more motor, and if we want to get the power to the motor, we are connecting one more generator, this one. So that is the combination of motor generator set. So this is also called a motor generator combination. So where we are using this one means in high power or high generation stations, we are using this method, Ward-Leonard control method. Okay, so apply voltage control method is divided into multiple voltage control method and Ward-Leonard control method. And another one is, if you want to use any power electronic devices, so it is called directly soft controlling method. Soft controlling methods. So soft controlling method is we are using any advanced technologies to control method. So, and here you will observe the speed is directly proportional to voltage. Speed is directly proportional to voltage means speed is controlled from 0 to maximum. Okay, but if you are going for previous case, one is flux control method, that is above rated speed, and armature control method, that is below rated speed, and voltage control method we have to use at anywhere. Okay, then okay, I'll have to take the snapshot because of my mistake. Graph this one. I'll have to take the snapshot. Then I will go for the next one, motor. And this is second one is Ward-Leonard control method and soft controlling methods. Okay, this is power electronic Development devices. So we are using applied voltage control method in 3 types: multiple voltage control method, old Leonard control method, and soft controlling methods, or any power electronic devices. And take snapshot for this one. And 1 minute. Flux control method means above rated speed, and armature control method means below rated speed. And third one is voltage control method, below or above. So take one snapshot, then I will go for the next topic.
Flux control, field control కూడా అంటారు కదా.
Just the overall view. Over.